Hello, this is Sharon Fisher, and Teledyne ISCO would like to welcome you to our webinar using 7 and 8.6 kilogram RediSep Gold columns with a torrent for large-scale separations. I would like to cover some housekeeping rules. First, if you have any questions during the presentation, please utilize the Q&A function within Zoom. All questions will be answered at the end. This webinar will be recorded and the video will be made available to you in the near future. Today we are joined by Josh Lovell, who is our product line manager from the Pharma Group. With that, I would like to turn it over to Josh.
Thanks, Sharon. So thank you for joining us today for our Teledyne ISCO chromatography webinar series. This month we'll be discussing using your 7 and 8.6 kilogram RediSep columns with the torrent for large-scale separations. So an overview of today's talk today. So first we're going to discuss some considerations for large-scale purifications. What are our goals? Then we're going to focus on the importance of choosing a stationary phase for scale-up in mind. Then we'll talk about how we can transfer a method from a smaller column and scale that up to our large columns. And then specifically, we're going to discuss how the CombiFlash Torrent can increase your throughput and specific instances of running sequential injections on the torrent with the solvent selection valve. And then finally, we're going to discuss our new IQOQ documentation and service options. So to begin, we'll be discussing large-scale purification objectives. So what kind of things do we need to consider for our purification? Is this a one-time batch or is it a repetitive process? And so how often are we going to be doing the process? How much compound do we need to purify? And what is that relative to the column size we're intending to use? So, and this is going to tell us how many injections we need to perform. How are we isolating the compound, or are we isolating a specific compound, or are we just removing an impurity from a sample matrix? What is the objective of our purification and what are our purity goals? So how pure is the initial sample to be purified? What's the necessary resolution of the method, and how pure does your target compound need to be? Do we just need 90% purity, 95% purity, 99% purity, or better? And then how can we load the sample? So what's the solubility of the sample? And this is going to dictate some of our decisions and how we'll performing our method. And the ultimate probably factor in a lot of our decisions is what's the cost of the purification. So column cost over time. So are we reusing a column? Do we want to do one large scale separation, or do we want to do multiple small scale separations on a smaller column? If we're doing a reverse phase, maybe the column cost is a little bit more expensive. And then obviously solvent usage is going to be a big consideration. That's going to be a bulk of the cost with larger separations. And then finally, what are your labor costs for processing the sample, and how many injections you're doing and setting up each injection. So the first case is we're going to consider just a one-time batch purification. So we've got a compound that's come into our, we just need to do a purification one time to kind of move on to the next step. So we've got a single batch of compound. This could be a single injection on a large column. This could also be multiple injections on a smaller column to save on our column cost. What are our method development goals? Are we just isolating a target material here? We want to focus on resolution around the peak of interest. Maybe an optimized method doesn't have to be a primary objective in this case. We can kind of do a longer gradient, knowing that we're going to get sufficient resolution and purification, and we're not concerned with solvent use because we're not repeating this purification over and over. We're more concerned about getting this turned around quickly and right the first time. So some goals here is you could do a scouting run on a small scale column, and you could generate a focus gradient using some of our technical notes for generating a flash focus gradient, either from an analytical run or even from a smaller scale flash run. Otherwise, you could use a default method. So you could run from 0 to 100% or 5 or 10% to 100%, even though this doesn't maximize the resolution. If you have a long enough gradient profile, you'll still get should get decent results for your separation, even though you'll be using more solvent necessary on your single run. You can then easily go scale up to the large column quickly from the optimized smaller column run. Considerations if we're doing a repetitive injection are a little bit different. So maybe we're going to do multiple injections, or we have a continuous batch of sample. So if we're doing multiple injections, we're looking for consistency from run to run. And we're going to probably spend some more time on method development, because this will result in significant time and cost savings with each future separation. So, once again, what are our method development goals? Is isolate the target material and then to maximize throughput. So we want to load as much compound as possible per injection, because we're doing a process over multiple injections, and each injection takes time, and you do that multiple times, it's going to add up. So any savings we can gain initially are going to be compounded later. So we want to maximize our sample loading, and we probably want to use an optimized method to go ahead and minimize our solvent use, waste generation, and minimize the run times that it takes to purify the compound. This also could contribute to smaller fraction volumes during workup as well, so you could see time saving there as well as a benefit. So in this case, it's suggested to go ahead and find a focus gradient to maximize resolution and give us an optimized method. You may even consider doing isocratic methods, because this eliminates the need for column reequilibration. That's something that you need to factor in. This also may allow solvent recycling outside the peak. So if you have a fairly clean separation, anything outside your peaks of interest or impurities, you could go ahead and recycle that solvent potentially. So that's something that could be an advantage to you in saving solvent costs and reducing waste. And finally, you need to look at column performance over time. Are we reusing the same column if we're doing multiple injections, or do we need to use a new column each time? Maybe we do need to do an occasional wash run every so many runs if we're reusing the column to remove any impurities that have accumulated on the column, to prevent any, consistency issues from run to run. And so those are things you need to consider over time and monitor. So what's the advantage of using Teledyne ISCO's RediSep material with our flash chromatography hardware line? And so the idea is that you can really scale up with RediSep. So we offer method development columns in UPLC and HPLC with matching chemistry. So you could do scouting runs on an HPLC, even for normal phase, and then transfer that method to our flash columns. You could do the same for C18 or any of our functionalized media as well. And so the starting point for method development could be either a past flash method that we've ran, maybe on a 4-gram, 12-gram, or 24-gram column, and then you could just go ahead and scale that up. Or we could do an HPLC scouting run, or even a quick TLC to kind of give us a starting point. Once we're happy with the method, we think we found a method that will work, we want to validate that method on the flash scale, particularly if you're coming from HPLC. Make sure everything translates when we go to the flash media. At that point, you'd want to then optimize the gradient conditions and the length for sufficient resolution. And we also then determine our sample loading and the volume that gives us baseline resolution. So we want to maximize the sample loading on the small column. From that, we can go ahead and scale up to our larger columns. So you could scale up to a 3-kilogram column, or even our 8.6 or 7-kilogram column. This large column is shown here. And so you can follow a scaling procedure to scale the method to the larger column and go ahead and perform that first run. If we're satisfied with the separation, now we can go ahead and set up a sequence for multiple injections without intervention, particularly with our reusable C18 functionalized or C18AQ functionalized medias. And depending on your flash separation, you could do multiple injections on that same silica column as well, particularly within the same day. So we'll talk a little bit more about that later. There's multiple choices that we offer in our RediSep line for stationary phases for different chemistries. And so some basic questions that you want to ask yourself are, what are the characteristics of my sample? Is it charged or non-charged? Does it have acidic properties or basic properties? Is it highly polar, or is it a lower medium polarity compound? And so depending upon your answer to those, we have multiple options to choose from, both in our irregular RediSep columns with our silica gel, with the gold 40 micron irregular media, and then we have a spherical 20 micron media that provides high performance, higher resolution, higher loading, which we'll discuss the advantages of later. But our functionalized media with the C8, C18AQ, the amine column, they all are offered in our gold line of media. So it offers higher loading and higher performance for those reusable columns. On the right here, you can see just the relative polarity of the media, where we have our normal phase silica that is our most polar media and binds compounds, and non-polar compounds will elute faster down the column. And then we have our amine C8, and then we have our C18 and then C18AQ functionalizations that have decreasing polarity of the stationary phase. So I briefly mentioned, our RediSep Gold media, and we offer that for both our bare silica, and then all of our functionalized medias are offered in our gold line of flash columns. And so the question is, why would you choose this? And so one of the advantages of the RediSep Gold media is that it's a spherical particle. So versus the irregular particle of the regular RediSep line. And so what this offers is that it packs easier and also generates lower back pressures compared to the irregular media, because you don't have any fines breaking off from the irregular particles. Additionally, it's a smaller particle size, so we see an enhanced resolution. And you can kind of see this with the graph on the right here, showing the sample load and the relative peak width for both the gold media and the irregular flash particle here. And you can see the peak width for the gold is significantly smaller for the gold RediSep Gold material versus the irregular particle. And so what this means is we can load more compound, or if we need the resolution, we keep the loading the same, but we have improved baseline resolution between our compounds. Or on the right here, you could run this same separation, same loading at a faster flow rate and over a shorter gradient period, and you'd be able to have some significant solving savings. And so in this run on a 40-gram column, you can run it over a steeper gradient because of the separation advantage there, and you could have a shorter separation by about 40 minutes here and save about 20 liters of solvent. And so that's an advantage both in time and cost and in sustainability. An additional advantage of the RediSep Gold media is it allows us to go greener with our separations. And so this is a really good illustration of some of the solvent savings you can gain, particularly as you scale up separations by maximizing your sample loading because of the stationary phase that you choose. And so we can see here for an easy separation here with the RediSep material, basically what it allows us to do is it allows us to go down to a smaller column size for the RediSep with the RediSep Gold material. And if we're doing that, we're going 24-gram to a 12-gram column, it saves us about 200 milliliters per separation because we're loading twice as much compound on there. We're running the gradient the same length. But if you go down to the 7-kilogram column and can scale that down to a 3-kilogram column by doubling your loading, now you're able to save 64 liters in this default method. So basically, you're going to half your solvent usage by being able to scale down double your loading on the RediSep Gold material. And just keep in mind, this is compound to compound dependent, but in general, you can kind of load about 2 times the amount of material on your RediSep Gold column versus your regular RediSep column because of the increased surface area and better packing and resolution of the separation. So what other benefits do our RediSep columns offer that you may not find on other competitor columns? And so one of the great things about the RediSep columns is when you use them with the CombiFlash Next Gen or Torrent or Easy Prep, is that it'll automatically recognize the column via the RFID tags that are on the columns. And so what it'll do is, one, it'll load a default method for you automatically, so you don't have to generate a method on your own. It'll pull in the correct flow rate, the correct column volume size. It'll automatically disable air purge if you're using a reusable column, so you don't destroy the column at the end of the run. And the additional benefit is that it'll go ahead and track column use information on your reusable columns. So it'll go ahead and write to the tag, and when you take that to another system, you'll be able to know what was the last solvent ran on that, how many times has that column been used, when was it first used, and when was it last used. And so this is on all of our columns, even our 8.6 kilogram column here. So additionally, this allows us to easily scale up from a smaller column to a large column on the CombiFlash systems, as those are built into the software. Our large columns, 750 gram, 1.5 kilogram, and 3 kilogram columns all have custom large inlets and outlets to minimize flow restriction, and this decreases back pressure at the higher flow rates. And you can also run these columns on competitors' systems with our large column adapter stand. For the next gen, you could also use that on other competitors' systems. You just need to see TechNote 60 on our website there for instructions on how to do that. The other great thing about our RediSep line is that we offer, from small scale to large scale, the same media. So we offer in our large columns all the way down to our smaller 4 and 5.5 gram columns, RediSep Gold material in silica, C18, C18AQ, C8, and amine stationary phases. So when you develop a method that only works on a certain media, you'll know that you can go ahead and you can scale up to 8.6 or 7 kilogram columns with our gold media. Additionally, we do offer our 7 kilogram columns in both the RediSep Gold and silver silica material. So moving on to the next segment of our talk, we're going to discuss method development, so how to transfer from the smaller column and scale up to our large. So as we discussed earlier in the steps of the process for our scale-up purification, one of the things we want to do is verify that the method on the smaller column works on the small scale flash column. This is particularly important when you're converting a separation from another media. So maybe you're moving from RediSep silver to RediSep Gold silica for your purification, or you're moving from a competitor's brand to our RediSep Gold because of the advantages in sample loading and increasing your potential throughput for separation. And the reasons for this is you do want to make sure that any potential differences in the stationary phase from the pore size, particle size, the carbon content, maybe just a difference in how the functionalized media is bonded to the silica, and then the loading capacity are the same, and you don't see any differences. So we'll do this on the small scale just to verify. And we may be able to take advantage of increased loading also of our sample on the new media. And so some of the advantage that you can see with this is that you should be sufficient. You want to look for sufficient baseline resolution while you optimize for gradient length and slope, so you can minimize the amount of solvent and waste generated and the amount of time for the run. And we want to maximize the sample loading amount, obviously, because we can load more sample and ultimately need less injections, and that obviously decreases things as well. Some things to keep in mind here is what solvent to use for injection, and what's the concentration of your sample, and how much can you load without influencing the chromatography performance. And then finally, we want to scale that up and verify the method on the large column. So how do we scale up to the large column? The best way to scale up is really to work in column volumes, and the reason for this is that the compound that elutes at 1 CV on a small column is also going to elute at 1 CV on the large column. It's a linear relationship there. So the column CVs should be provided with the column. However, a lot of methods are found in minutes versus CVs, and in this case, you would then need to convert the segments in minutes to column volumes, and you can follow a spreadsheet like shown below here. And so you guys can access this via our website. There's a technical note describing it. And basically what you need to do is if you follow a spreadsheet like this, you enter the time of each change in the gradient in column A, enter the %B at the beginning of the segment, and that'll go ahead and generate, and then the flow rate, and then that'll represent the segment length in column cell A3 and A2. And then we can look at the solvent volume used for each segment, and then the CV is used for the method development column in column F, and fill that down. You can calculate the segment length of each gradient in column G of the spreadsheet. This enters the column volume to the large column in column H, and then fill down your new column volume size. This will then generate you want to go to enter the proposed flow rate that you'd like to use for the large column. And then we can calculate the gradient segments of the large column and convert that to minutes. Convert the segment length to total minutes by using column K there. So then we'll have the correct time periods for the segments now in column K. You go ahead and plug this the gradient segments into your new method. Like I said, you guys can follow this with a technical note on our website as well. So at this point, we're going to be able to maximize our loading amount. So the easiest way to increase throughput is to maximize the sample loading. So we're doing more on a per run basis. So general sample loading parameters is the mass of the sample to the mass of the column media. And so for functionalized media, C18, C8, amine, C18AQ, this could be anywhere from 0.1 to 2%. For bare silica, because it's not functionalized, it has a lot more sites for interaction, and we can actually go from 0.1 to 20% loading, depending on your baseline separation. These are just starting points, as I mentioned. And so for example, for the removal of THC from CBD, customers could load up to 10% of the column size on a C18 media, which is drastically overloaded for what most people are used to using on C18. But the nature of their purification is that they're just removing THC from the CBD oil. They don't need high resolution. They just, they don't mind the other impurities with the CBD, but the THC needs to be removed. A general rule of thumb is that the scale up proportionally from the size of the method development run to the large column. So as an example, if you're using a 100 gram RediSep C18 gold column for method development, and you verified the conditions or work, you've got baseline resolution, you should then be able to scale up to a 2 gram sample load on that 100 gram column to 6.6 grams on a 415 gram column, 76 grams on a 3.8 kilogram column, or 189 grams on an 8.6 kilogram column. So what potential issues do we need to be aware of and consider when we're scaling up? So one of the main concerns when we're scaling up is, how much sample are we loading, and the potential for any effects of the chromatography from our dissolution solvent. This is the same for small scale and a large scale, but it's something to be aware of, especially when dissolving large amounts of compound, as the dissolution solvent can have a major impact on the chromatography and loading. In some cases, particularly in peptide and oligonucleotide purifications, these customers are able to load large dilute volumes of their sample in weak solvent, and it doesn't cause any problems with the separation because the solvent's so much weaker than the compound's not traveling down the column at that point. It's just sticking at the top of the column, essentially. This really compares to our ideal situation as a basic premise in chromatography is to load in a solvent that is weaker than the starting chromatography conditions. However, this is usually the exception and not the norm. The torrent makes it easy to load large sample volumes, but we need to be aware of any potential effects it may have on the separation. So how do we reduce peak broadening from loading? One is to dilute the distillation solvent with a weaker solvent before loading. This could be your A solvent, anything to make the loading conditions as close or weaker than the starting conditions is always going to benefit your separation. Additionally, we have some customers who actually will do an equilibration in a slightly weaker solvent than the starting conditions, And this works well when you have a high %B starting condition. And the weaker column equilibration helps to dilute the strength of the injection solvent. So maybe you have some solubility and issues during loading there, but if you have a slightly weak solvent on the column already, it kind of dilutes that, and it doesn't allow the compound to travel down the column significantly before the separation. So here's a visualization on the importance of the choice of your dissolution solvent. So this is just a separation with a colored compound, so we can view it both on the column and via the chromatogram. And on the left here, our compound's been dissolved in a strong solvent, and the sample on the right is dissolved in a weak solvent. And you can see the compound is eluted significantly down the column, even during the loading portion of the method, versus on the right there, where you actually have two pictures. One on the top is when the samples, after the sample's loaded, we don't even see any compound on the column yet. And then as it travels down, starts to elute down the column, once we get a strong enough solvent composition, we actually see a nice tight band of the colored compound. And you can see the bandwidth and the separation as well, going from something that is over, 6 to 8 minutes with significant peak fronting there on the left, to something that's about 4 minutes wide on the right. So significantly better baseline resolution if you were to have compounds next to it. You can visually see it on the column as well. Another example of choosing alternate dissolution solvents in this case, and this is an example from Prep HPLC, but this would be applicable to Flash as well. And basically, we're looking for a compromise between good dissolution while minimizing the effect on the integrity of the chromatographic separation. So I have two runs here. One's dissolved in 1 milliliter of DMSO. And so this is a satisfactory run. We've got baseline separation between peaks 2 and 3 there. There is some, you see the DMSO peak is peak 1, and then some compound, it looks like tailing with that. But we're really interested in peaks 2 and 3 and the separation there. That's a 1 milliliter injection. When we inject 2.5 milliliters, now we've got significant fronting of peaks 2 and 3 into that initial peak, and we're not seeing baseline resolution between those two peaks, or additionally, between peaks 1 and 2 as well. And so this isn't a satisfactory separation for us. We're not going to be, we're contaminating our where we had pure peaks before. Now we're contaminating them since we've overloaded it, and wider peaks. So what could we do? Well, we could try a different dissolution solvent. And so in this case, our compound's also soluble in water. Sometimes this isn't going to be the case, but if we can choose a weaker dissolution solvent, this is a good example. And so we were able to dissolve it in 2.5 mils of water, and the chromatogram up on the upper right there shows that we still have baseline resolution. This is the same concentration as what was dissolved in the DMSO. And you can compare that to the example on the lower left there and see that's a better separation. On the lower right, though, we've actually been able to increase our loading to 4 milliliters of the same concentration in water. And so now we're able to actually load more compound onto the column and actually increase our throughput, because we've been able to maximize the amount of sample actually getting loaded on. And essentially when you're loading that on in water, it's just sitting on top of the column. It's not traveling, it's not eluting with the strong sample solvent pushing it down the column. So that's the importance of loading both on prep HPLC scale, but it also applies to Flash as well. It's a really good example. So what are some of the advantages that the Torrent offers us, or options that the Torrent offers us for loading our sample? And so two standard options you can do on the Torrent is you could do liquid injection with the liquid injection via syringe as an option. The Torrent comes standard with an injection valve that enables true walkaway, automation of column equilibration, your sample loading step, purification, column and cartridge air purge, and post-run valve cleaning. So all that's automated in the background for you. That way, when you go to do your next run, it's ready to go. For loading, you can do liquid loading, or you could do solid sample load cartridge loading. And so this is obviously a huge advantage. We've talked about this in the past, but solid load loading onto the cartridges basically gets rid of that any effect from your dissolution solvent, and it can eliminate that for your tough to dissolve compounds. You can dissolve it in a strong solvent, absorb it to a C light or a silica media, evaporate it down, and then load it into your cartridge. And so we offer empty cartridges for that purpose. Additionally, you can use the pre-packed silica cartridges also, and then just let those dry as you load the compound as liquid on there, and dry those out before you do your separation. Additionally, we have some customers who kind of use that as a guard column for their reusable columns as well, because it's going to collect any of the particulates and act like a filter before it gets to your column. So that's an advantage too as well. And so on the software here, you can see kind of the different loading options. And so your run requirement screen here shows the necessary solvent requirements for the run. In this case for water methanol, we're going to use 1.4 liters of water, 1 liter of methanol. Your RFID tag on the, if you're using a Foxy, which we'll talk about in a sec, will tell you what rack size is loaded on the Foxy and where your starting positions are. And then finally, you can choose the 4 different options. You can do solid load pause, where you do the solid load cartridge, and then it'll wait until you're ready to go to begin the separation after the equilibration occurs. If you've already loaded your solid sample load cartridge onto the system and you're ready to go, it'll do equilibration and automatically go into the injection and then the gradient automatically without user intervention. And you could also do liquid injection via syringe traditionally. You could also do runs where the sample is loaded directly onto the column, or maybe you'd have sample in the column that you're trying to wash out, or you're washing the run, or washing the column. So how can we get more out of our large separations with the Torrent? So the Torrent is offered in 2 different options. One is the Torrent, and then one is the Torrent AQ. And the Torrent is designed for normal phase separations, and you can also do reverse phase separations on it. The Torrent AQ is dedicated specifically to reverse phase separations. And this is the reason for this is that there's different pump materials in both instruments, and the Torrent AQ has pump materials that allow for reduced downtime because it's using reverse phase solvents. So you can use a different material that's longer lifetime and is compatible with the reverse phase. The normal phase Torrent, because of the solvents that you're using, you have to use a different material, and it does have a little bit shorter lifetime than what's used with the Torrent AQ on the A pump. Additionally, the solvent selection valve module is a new feature that's been introduced recently, and this allows us to do some advanced separations because now we have 2 B solvents we can choose from. And we also have a sample inlet line that allows us to do sequential purifications without any user input. So when we're doing like a separation on the C18 column or any of our functionalized media, or maybe multiple separations on a silica column, we could do multiple injections of the sample. Additionally, we continue to put new features in the Torrent software, in our Peak Track software, with free updates, improvements over time, and those are always something we can consistently get user feedback and see their processes, and we document what you guys need, and we try to implement that as best that we can on our existing systems, and are constantly updating that. And the solvent select valve is part of that. So it allows us to increase our throughput by allowing for unattended operation to process batch samples. And then finally, we've added a new range of columns, a new scale here. So we have our 8.6 kilogram and 7 kilogram columns for our in all of our gold silica and silver silica, and then also RediSep Gold C8, C18, C18AQ, and amine medias. And so multiple options to fit your purification so that when you find a media that works for you, you know that you'll be able to scale up with RediSep. When we're doing large-scale separations, the CombiFlash Torrent is designed with large-scale purification in mind. It takes all the friendly user interface that you're familiar with our next gen and our CombiFlash next gen software, Peak Track, and then allows us to scale up for 1 liter a minute flow rate. Can deliver any binary gradient from 0 to 100%. At high flow rate, multiple solvents, water, acetonitrile, methanol, DCM, hexanes, ethyl acetate, and many more are all compatible on the system. You can purify up to 1.4 kilograms per run, depending on what your media and your resolution is. And so we can do larger columns, increasing your loading capacity, increasing your throughput, and decreasing the amount of time that you're spending running multiple columns at smaller scale. Obviously, the peak track software we discussed, active solvent and waste level sensing, lots of safety features, compact benchtop design, so we could use this in a lab still. You don't need a specific space design for it, although you can use it in those spaces as well. And you can configure it to meet your needs. So you can choose the system modules you need. So do you need a UV vis detector, ELSD optional? What are my fraction collection options? How am I doing sample loading? We have modules to meet your needs for the torrent there. So the torrent offers numerous safety features that you should be considering when you're scaling up. Probably one of the most important ones is a standard vapor sensor on the torrent. And what this does, it automatically detects leaks and automatically stops the system if a vapor is detected due to leak. And the reason for this is because you're running at such high flow rates, a small leak, and if the system's running, can lead to a large mess or hazardous condition. And so that's automatically taken care of. Additionally, there's pressure sensors to detect for blockages on the column and the system to prevent damage to the system, damage to your column, a separation that you need to redo or a lost compound. Additionally, the system's able to air purge, and this allows for easy disposal of the columns or solid load cartridges. It minimizes exposure for the chemist to solvents on the column and easier cleanup. Additionally, there's an audible alarm when user intervention is required, and there's static dissipative tubing throughout the system because we're working at such high flow rates with these solvents. There's a patented solvent and waste level sensing on the system. So, before we run out of solvent, it's going to let you know. It's going to let you know how much solvent you're going to need for the run, and then it'll stop the system from overflowing if it generates that the waste container is full or you've run out of solvent. You're not going to run your column dry. And also the ability to network the system and monitor progress from anywhere. So we talked about some of the module options on the torrent. One of those is the Foxy R2 high flow fraction collector, as shown on the right here. And what we can do with this is it offers us RFID rack identification technology on our fraction collector. So it'll detect automatically what size rack you have in there. Do you have a bottle rack? Do you have a test tube rack? What are the positions? We can define what positions we're going to. You can use a funnel rack to collect unlimited quantities in any container. You can also chain up to 4 of these Foxies together on the system to increase your fraction collection capacity. You can collect based on volume with triggers. You can detect from threshold, slope, and or time windows for this. And this is a great tool when you're doing an initial method development. You need to find out where your peaks are coming out. You want to fractionate accordingly because you can take smaller cuts with your test tubes or your bottles versus what you would do with a kind of a bulk separation. And you can establish time windows on a scaled up column. Another option is the fractionation valve, and so you can have systems with both of these on here, and you just switch between the two depending on what purpose or the purpose of your separation. The torrent fractionation valve allows you to collect up to 6 fractions and a separate waste for defined protocols. So when you're scaling up and doing a process and you have a consistent separation, you can set up time windows to say, okay, I want to collect this in time window 1, fraction 2, time window 2, so on and so forth. Additionally, you can go ahead and you can trigger collection based on slope threshold as well, but you're limited to 6 containers or 6 fractions. This is a really good choice for multiple injection samples, and we can collect into the same, you can essentially do fraction pooling this way, and it allows you to do fraction pooling into the same container over multiple runs. So how does this solvent selection valve allow us to do increased loading and increased throughput with automated loading. And so the advantage here is that you'll notice a difference on the interface here in PeakTrack is that it basically asks you, what's your total sample volume? How many injections do you want to perform? And then what flow rate do you want to load the sample on? And the reason for this is if you're loading in a viscous sample, you may need to load at a lower flow rate to avoid overpressurizing the column and damaging your column during the separation. And the solvent selection valve here basically adds capabilities to the system. So one, it turns your B solvent line into a B1 and a B2 solvent line. And now we can do any binary gradient between solvent A and B1 and B2. And you can change from B1 to B2 during the run. So you can actually change solvents during the run if you have a wash step built into your protocol. And the wash step could be really important depending on if you're doing repetitive purifications on the same column. You could get impurities that start to build up over time. You need to wash those off so that you can get consistency from separation to separation. And those are things to be aware of multiple runs into the separation. If something starts to change, well, maybe you need a column wash to get those impurities off the column. It also adds a sample inlet line for the loading liquid sample onto the column with the B pump. This introduces the ability to run sequential injection on the same sample without user input. Some general guidelines for this. For best chromatography, you would want to choose as weak a dissolution solvent as possible, as we discussed before. For some samples, it may be a good practice to stir or gently heat the sample to ensure that you have good diffusion and an even concentration of the sample throughout. The sample must be free from particulates, as this is pumped through the B pump on the system. So any particulates could damage the pump. So you want to make sure that it's well filtered and there's no particulates in the system. The solvent needs to contain less than 90% hexane in order to prevent any premature B pump failure. Also, that's another consideration as well. If you're using normal phase chromatography and maybe an isocratic method, or it's a gradient method that doesn't start at 0%, you could go ahead and do multiple injections on the same silica column. If you run a gradient from 0 to 100% though, it's difficult to reproduce that first run on the subsequent injections, because once you have put the polar solvent on the silica, you start to change that initial silica selectivity now. So injection 1 is different from injection 2 at the beginning, and you might see some changes after being exposed to the polar solvent. The other thing you want to be aware of is that the column body can swell with some organic solvents over time, like hexane. Now, if you're doing like back-to-back purifications over the same day, it's probably not a big deal to reuse the column. But if you're doing it over multiple days, you need to be aware that you should be storing your columns in IPA, and that may change the selectivity of your column over time as well for your silica. But for the reusable columns, you want to make sure you're storing your columns properly. So here's an example here of 8.6 kilogram RediSep Gold C18 column being used with the CombiFlash Torrent using the solvent selection valve for multiple unattended operations. This is with 10% sample loading on the column and a 1.6 liter injection. And so for this purification, this is remediation of THC here, but we can see the difference. There's no difference in performance between run 1 and 20 on the column. So the column's still performing after 20 injections here. We still see the THC being well separated from the CBD peak. So we have good separation there between those two major time windows there, and there's not a significant change in the performance of the column over these injections. And so they're taking advantage of the increased throughput offered by the solvent selection valve, coupled with the large size column, the 8.6 kilogram column, to purify a significant amount of compound over and over again. So the final portion of our talk is that we want to discuss some of the new documentation and services that Teledyne ISCO is offering, specifically for the CombiFlash Torrent, so that it can be better used by customers in potentially regulated environments. And so in support of our customers, ISCO has a very strong quality system. So we have we are ISO 9001 accredited. We have documented system development life cycles, controlled documents, robust internal quality management system, which includes vendor audits, factory calibration of each instrument, internal audit processes. Additionally, we have a very strong service department that is available for our customers as a resource, but and also to perform service to maintain and keep instruments up and running. We offer preventative maintenance and service contracts. We pride ourselves on educating our customers and offering support to answer customer questions so that they're knowledgeable users and aware of any nuances of the process or the system that they should be aware of and considerations that they need to look out for. And finally, we offer regular training of all of our service personnel, installers, and our distributors who are performing service on our instruments. So one of the newer items that we'll be offering is that we're going to be offering installation and qualification services to be performed by our qualified service technicians or factory qualified distributors. And what this does is it provides a verifiable document trail to show, they'll provide a verifiable document trail, show training of the individuals performing the service and qualification of the instruments and of any work performed on these specific instruments. Additionally, there's a ready-made documentation package written by us for the instrument. And this includes detailed procedures for installation qualification, operation qualification, and preventative maintenance processes. Once again, this provides a verifiable document trail for you, the customer, to have that shows due diligence and records of upkeep for the system. And this allows our customers not have to create IQ or OQ documentation from scratch. And so these are offered as an additional service to our traditional installation. And the documentation that's included with these services from either the distributor or the factory would be a certificate of calibration with the instrument, an installation qualification procedure that includes a pre-installation qualification checklist, operational qualification including a pre-operational qualification checklist, and preventative maintenance that is for regulated environments, and this includes the preventative maintenance checklist. And so to understand kind of the qualification cycle here, and as you have the initial system purchase or an existing system in the field, if it's in the field, it needs to be evaluated to ensure that the system can be qualified or brought up to current standards so that it can be qualified. So after installation, service would perform an installation qualification, and anytime an additional module is added to the system or location is changed on the system, then you would also need to do that as well. This would be then immediately followed by an operation qualification, and this would follow any IQ, PM, or major service. Performance qualification is something that you, the customer, would perform, and this is specific to the process that you're working on. And this is designed and performed by the customer. And then we suggest a PM every 6 months, but this could be variable depending on usage and whatever your standard protocols are for your site and the instrument and how it's being used. But anytime after a PM or a service, that our service or distributor is performing, you would then do requalification of the instrument with a OQ again. And this would happen after any PM or service. And so you kind of go into this cycle here of repeated qualification over a set period of time. So in conclusion today, we discussed considerations for large-scale flash purifications, from single batch purifications to repetitive multiple injection separations. We explained the differences to consider in moving up from small scale to large scale purifications and how we do method transfer and validation. We described why you would want to choose RediSep Gold media because of increased sample loading and potential savings in solvents for larger processes. We also, reiterated the different choices and stationary phases that the RediSep Gold line offers, including silica, C18, C18AQ, C8 and amine functionalizations, and then also our RediSep silver silica as well. Additionally, we discussed how the CombiFlash Torrent offers multiple modules and tools to increase your versatility with increased throughput and efficiency, including the solvent selection valve to do multiple injections, different fraction collection options based on whether you're doing validation or you're just doing a bulk process like with the fractionation valve or the Foxy R2, a high flow fraction collector. And finally, we introduced our new instrument qualification services and different documentation options that accompany that. Basically new services offered by trained service personnel as an additional option that you can add on to your installation that offers a documented paper trail for the installation qualification, the operation qualification that you may need to do on a regular basis in regulated and controlled environments. This time, I just want to remind you guys to follow us on different social media platforms, including Facebook, Twitter, LinkedIn, and YouTube. At this point, you guys can go ahead and scan any of these QR codes to follow us on our social media, and we look forward to interacting with you guys there and sharing experiences that way with you. So, at this point, I'd like to open it up to questions.
Hey guys, just as a reminder, you can use the Q&A function in Zoom there to submit any questions, and I'll try and get them answered. So we've got a couple already, so just let me digest them here and get them presented. So one of the first questions here is related to our columns, our large scale columns, and just kind of a question on just general availability. So I just want to, remind everybody here that we've got multiple stationary phases available that you can scale up from 4 gram on flash up to 8.6 kilograms on in flash as well on the torrent there. So all of those medias, the RediSep Gold silica, the RediSep silver silica are available in a large size, so that's something that you could scale up on. And then any of our alternate phase medias like C18, RediSep Gold C18, RediSep Gold C18AQ, RediSep C8, and RediSep amine columns are also packed in the 8.6 kilogram size. So if you're doing, if you have a unique compound separation where you need to use one of those stationary phases and you find that product needs to be scaled up, you have the tools available to kind of scale up with your needs there. The one column the one media we do not pack in a large size is the alumina. That's not packed in the 8.6 kilogram size. It doesn't pack as well in the large columns as our silica material. And so it doesn't offer a consistent, robust solution. So I just do want to point that out. That's why we didn't mention the alumina phase in our selection guide, although that is a good tool for acid sensitive compounds, but we can only go up to I believe 330 gram size columns with that media. Okay. So another question here is, being a new user to the torrent, what potential customers and applications could be? So really, this is the torrent is a low volume product for us because a lot of compounds in manufacturing or in development don't need to be created on scale. So when companies have success with a compound, they need to begin making more and more of it, either for testing or further development to meet needs. So the torrent's used a lot to purify intermediates and separations where they need large quantities. We also see it in some manufacturing environments as well, actually producing compounds in some GMP regulated processes. And application areas we've commonly seen it in would be kind of a natural product purification, like with CBDs and cannabinoids, pharma, small molecule, in peptides is another growing area that we're seeing a lot of interest in, oligonucleotides as well, where they're looking to scale up and do multiple separations on like a C8 media or the C18 or the C18HQ. Is another stationary phase that has some good success with some of those compounds. So there's several different choices that would be useful in the peptide oligonucleotide market as well. Let's see here, got a couple other questions here. So a question here about the gold media, and why does it perform better than the silver? So one of the big differences between the gold and our silver RediSep is that the gold material is smaller particle size, so it packs more efficiently. It's also a spherical media, so spherical particles actually will pack more efficiently as well. And sometimes the problem with irregular media is that it'll generate higher back pressure at smaller particle size as well. So the spherical particles allow us to go down to smaller particle size, which gives us increased packing efficiency and better separation compared to the larger particle size of the silver media. And there's a couple different outcomes of that. We highlighted peak width of similar loading size, right? That's a big one. But the question is, how do you take advantage of that? And so there's a couple different ways. One, you could increase the loading of compound if we have better peak width or resolution, right? So you can load more sample, increase throughput that way. Two, maybe you've loaded all the sample you need to, so that's not a concern to load more. You just want a faster separation. So you could do a shallow or a steeper gradient or a shorter purification process and save solvent that way. So that's another advantage. And the other thing is it also would allow you to run at a higher flow rate because the Van Diepter curve would be a little bit more forgiving compared to the irregular media. So you can take advantage of the resolution that way and run the method faster. And that's what our gold speed method does on our traditional flash systems. So that's always an option there for our customers. A couple other questions here. Let's see here. So additionally, regarding the gold, all of our functional media are gold column is a gold spherical media. Once you get to the functionalized columns, because they're reusable, we use the smaller particle size and the spherical particle because of the higher efficiency, and because it's a reusable column, you want to get the maximum performance out of that column. So with that, I appreciate your guys' time today. The presentation will be shared online. It'll be available on YouTube along with our past presentations. And we appreciate you guys taking the time and hope you have a good rest of your day. Thanks.